Hello everyone. Today we'll be presenting our project, the Cognitive Complexity Estimator. This tool is designed to measure how cognitively demanding a piece of writing is, using a combination of linguistic analysis and machine learning. In many real world situations like education, content designing, marketing, and even AI evaluation, we need to understand not just how long a sentence is, but how mentally difficult it is to process. Traditional scores like flesh or smog mainly rely on surface features. However, cognitive complexity is influenced by much more like syntactic structure, lexical sophistication, surprisal conceptual density. This project aims to capture these dimensions using modern NLP tools. For this project, we have sourced our dataset from Kaggle, which includes human annotated measures like BT easiness, flesh reading ease, and smog. Using Spacey word frequency, a surprisal model based on Distal GPT-2 and sentence transformer embeddings, this app extracts syntactic complexity features, the lexical sophistication metrics, cohesion features, surprisal and perplexity, and the dense semantic embeddings via mini-LM.
So at the back end of the application, we have built a multi-output XGBoost regressor, which predicts the three target scores. This model was fine-tuned with randomized search cross-validation with a range of hyperparameters. So before training, we first cleaned and pre-processed the text to create tokens using the Spacey module from the NLPK library. We then measured lexical difficulty using word length, vocabulary rarity, and lexical diversity. We also examined cohesion, looking at disclosure connectives, pronoun use, and content overlaps. Apart from this, we added surprisal score using the Distal GPT model and sentence embeddings from a transformer to capture deeper semantic relationships, especially using the mini LM model. These high dimensional embeddings were then reduced using PCA. All these features form a detailed representation of the text at both the surface and cognitive levels. These features were then passed as input for the model training, and the model performance was evaluated using the Pearson correlation coefficient. Finally, we ran an ablation study to understand which feature groups contributed most to the prediction.
So now I'll demonstrate the application. The interface is made on Streamlit. The interface is also intentionally minimal and clean. Users can either paste the text or upload a .txt file, and when they click Analyze, the app runs a full cognitive analysis pipeline. On the right, the model information is displayed, including the embedding model used and the feature space. I'll paste a sample text over here, and it should analyze and give the estimated scores. These are the scores of this particular sample text. Now I'll upload a file, and after analyzing, it gives the scores of that particular text. So below are the predicted scores that appear. These include the BT easiness, flash reading ease, and smog readability score. The system also generates the estimated difficulty level, which could be elementary, intermediate, or advanced based on the flash reading ease. In this case, it is advanced. In addition to that, the app also provides suggestions on how to increase, on how to uh, adjust the text depending on your goal. If the user wants to make a text more advanced, the app suggests the ways to increase the complexity. And if the user wants the opposite, it also suggests the how to reduce the complexity of that particular sentence. And here is the processed input text, which is a cleaner version of the text which is uploaded in the input part. Thank you.